Assalamualaikum and hi everyone. Today we continue geometric sequences. After this, I hope all of you will find the nth term and can find the sum of the first nth term for this sequence. Okay, now take out your note and we will start now.
3.3 Geometric sequences. Definition: a geometric sequence is a sequence of numbers in which any term can be obtained from previous term by multiplying by a certain number called the common ratio. The terms of a geometric sequence are given by AR square, AR cube until AR power of n minus 1, where A is the first term and R is the common ratio. This one formula n term for geometric sequence where Tn equals to AR power of n minus 1. And this one formula for R, common ratio, where we can get from second term divided by first term, or we can use third term divided by second term, and general formula for this ratio is Tn divided by Tn minus 1. Okay, first question. Find the general term for the geometric sequence 8, 16, 32 and 64. General term means we want to find Tn. Okay, to find Tn, we know this one is geometric sequence. So our formula is Tn equals to AR power of n minus 1. Then we check from the sequence. Our A is 8 and R is 16 divided by 8. We get 2. Then we substitute into formula. A is 8 and R is 2 power of n minus 1. Okay, to solve this one, we use concept of index. So 8, we can change to base 2. 2 power of 3. 2 power of n minus 1. Okay, since the base is same, so we can combine the power. So become 3 plus n minus 1. Then we solve 2 power of 2 plus n. So we conclude the general term for this sequence is 2 power of 2 plus n. We go to question number 2. Find the ninth term of the geometric sequence 27, 9, 3 and so on. We want to find ninth term means we want to find T9. Okay, T9 for geometric sequence is AR power of 8. 8 come from n minus 1. N is 9. So 9 minus 1 we get 8. Okay, from this sequence, we know that our A equals to 27 and R is 9 divided by 27. So we get 1 over 3. So we substitute. Our A is 27. R is 1 over 3 power of 8. We can direct solve with calculator. Then we get 1 over 243. Question number 3. The nth term of a sequence is Tn equals to 2 over 3 power of n minus 1. First question, show that the sequence is a geometric sequence. Okay, to show this sequence is a geometric sequence, we use formula R. Okay, R is Tn over Tn minus 1. We must show the value of R or the answer of R must equals to constant. Constant means number. Okay, now first step, we find equation for Tn minus 1. Since we have already Tn, now we find Tn minus 1. Okay, to find Tn minus 1, we replace n with n minus 1. So 2 over 3 power of n, and we replace with n minus 1, then minus 1. Then we solve, we get 2 over 3 power of n minus 2. Okay, now we want to show is it R equals to constant, so we use formula R. So R equals to Tn. Equation for Tn is 2 over 3 power of n minus 1. We divide by Tn minus 1. We already find 2 over 3 power of n minus 2. Since this one is concept of index, so we use properties. If divide and the same base, we can minus the power. So n minus 1 minus with n minus 2. Then we solve, we get 2 over 3 power of n minus n cancel, negative 1 plus 2, then we get 1. So r equals to 2 over 3. Okay, then we conclude. Since the ratio r equals to 2 over 3 is constant, so the sequence is a geometric sequence. Question B, find the value of n where Tn equals to 256 divided by 6561. Okay, we have Tn equals to 256 divided by 6561. Okay, question also given Tn equals to 2 over 3 power of n minus 1. Since both are Tn, so we can compare both Tn. So 256 over 6561 equals to 2 over 3 power of n minus 1. Okay, now we try change 256 in base 2. We use calculator, we try, then we get 2 power of 8. And also we try for 6561, change in base 3, then we get 3 power of 8. Okay, since 2 and 3 have a same power, so we can combine all together with power of 8. Okay, since the base is same, so we can compare the power. So n minus 1 equals to 8, n equals to 9. We finish for n term. Now we go to the sum of geometric sequence. For sum, we have two formula. First one for r less than 1. So we use Sn equals to a, 1 minus r power of n divided by 1 minus r. Or if r greater than 1, we can use Sn equals to a, r power of n minus 1 divided by r minus 1. Actually, we can use both formula for any types of r. We continue example number 1. Find S5 of the geometric sequence in which a equals to 27 and r equals to 2 over 3. Now we want to find sum of the first 5 term. Since r less than 1, so we use formula Sn equals to a, 1 minus r power of n divided by 1 minus r. Okay, then we want to find S5. S5, so we substitute a equals to 27 and r equals to 2 over 3 and n equals to 5. Okay, divide by 1 minus 2 over 3. Then we use calculator, we solve, we get 211 over 3. Question number 2, the first term of a geometric sequences is 27 and its common ratio is 4 over 3. Find the least number of terms the sequence can have if its sum exceeds 550. Okay, now question given first term. First term means a equals to 27 and common ratio r equals to 4 over 3 and 4 over 3 is greater than 1. The question asks to find the least number of term. The least number of term refer to n. And given sum exceed 550. Formula for sum geometric sequences is Sn equals to, this one r greater than 1, so we use a, r power of n minus 1 divided by r minus 1. And then question given exceed 550 means Sn is greater than 550. So formula a, r power of n minus 1 divided by r minus 1 greater than 550. Okay, now we substitute value for a and r into formula. So a is 27, r 4 over 3 power of n minus 1 divided by 4 over 3 minus 1 greater than 550. Then we solve 27, 4 over 3 power of n minus 1 divided by 1 over 3 greater than 550. So we solve again, then we get 1 over 3 times with 550 and 27 divided by 550. So we get 4 over 3 power of n minus 1 greater than, okay, we get 550 divide 81. Okay, we plus 1. So we get 4 over 3 power of n greater than 631 over 81. Since we can change the base, so we use log to solve this problem. Okay, we use log, so n log 4 over 3 greater than log 631 over 81. Then we get n greater than log 631 over 81 divided by log 4 over 3. Then we calculate using calculator. So we get n greater than 7.1359. So we conclude n equals to 8. This question for your exercise. If you have any problem, you can ask your lecturer. Okay. Question number 4. Chan save RM50 in January, RM100 in February, RM200 in March, and so forth by doubling his savings every month for 1.5 years. Find how much he saved in the month of October. Okay, we can create sequence from this story. He saved RM50 in January, so 50 is a first term. Next month he saved 100, and next month he saved 200, and so on. From this sequence, we can find A 50. Since doubling, so we use geometric. R common ratio is 2. Okay, now question asks to find how much he saved in the month of October. This one is January, first month. Now we want to find in the month of October, means we want to find 10 months of this year. So we find T10. T10, we use formula for geometric, is A is 50, R 2 power of 10 minus 1. So we get answer RM. So we get answer 25,600. So we can conclude he saved RM 25,600 in the month of October. We go to question number 5. The price of the tin of milk powder increases by 3% at the end of each year. If the current price of a tin milk powder is 38 ringgit, find the price of a tin of milk powder after 5 years. If question it given increases or decreases by percent, so this type of question we use geometric sequences. Question given current price of a tin milk powder is 38 ringgit. So the first term is 38 ringgit. And to find R, we use percent that given by this question. Question given increases by 3% means we take 100% plus with 3%. So our R is 1.03. Okay, and question asks to find price of a tin of milk powder after 5 years, means that we want to find T term, Tn. So we use formula Tn equals to AR power of n minus 1. And question asks to find after 5 years, means we find T6 after. So to find T6, we substitute value for A. A is 38 ringgit. R is 1.03 and power 6 minus 1. Then we solve 38 ringgit. 1.03 power of 5. Then we calculate, we get 44.05. Then we conclude the price of a tin of milk powder after 5 years is RM 44 ringgit and 5 sen. Okay, now we go to the last question. Each year, the price of car depreciates by 10% of the value at the beginning of the year. If the original price of the article was 50,000, find its price after 10 years. Okay, this type of question is also given in percent. So, when given in percent, so we use geometric sequences. So, for this question, I skip, and I hope all of you can try to solve it. And you will get answer RM 17,433 ringgit and 92 sen. This question for your exercise. If you have any problem, you can ask your lecturer. Okay, we already finished chapter 3 sequences. So that's all from me. Thank you everyone.